All right. So you had a question on your bonus, okay? It looked like this funnel, and they said, what is the volume of this funnel, okay? And what you had to see was, while they gave you H's and R's, you had to see that if you replaced all your R's with X, and you replaced all your H's with Y's, it would have been a problem that was exactly what you've been working with me, okay? So if this had been the x-axis and this had been the y-axis, remember they gave you r is equal to what? R is equal to, was it 1 over 23 plus h squared? That was really the same as saying, remember r is your x direction. That was really the same as saying x is equal to 1 over 23 minus y squared. Okay? And let's think about this problem. I'm going to change it to r's and h's. Okay, but it was really the same as x's and y's. Okay, so I'll change this to h. Okay, what you want to do is, if you think about this figure, you're rotating to get the volume of this. You see, you're rotating about the y-axis, right? If you want the volume around a y-axis, you already know it's a dy problem. Okay, and if you think about this, if I rotated this region, let me grab this region. If I take this region right here, let me highlight it. If I take this region and I rotate it, okay, sorry, I failed kindergarten. Okay, and you rotate it about the y-axis. Do you see it be the funnel shape, right? And how do you get your r? Remember, your r is from the axis of rotation through the region to the furthest point of your region. There's your big R, right? And if you took slivers of this thing, if you took this whole region and you took cross sections of this region, okay, and I took out one sliver, what shape would all of my slivers be? There would be circles. So this area was actually pi r squared dy. And what was my r? My r was actually this x minus this x. Well, this x here is just, let's see, this is volume. So this r was 1 over 30. Oh, sorry, 1 over 20, thank you. 3 plus h squared minus, guys, what's this x right here? 0, okay? So r was really 1, I'll do r squared. R squared was really 1 over 400, 3 plus h quantity squared d, and it's not dy, it's actually dh. Okay, and that was a formula. If you could get that formula, you're probably on your way to getting the answer right. This is an h, so what I want is my lowest h value, which was what? 0. And what's the highest disk I wanted to account for? 10, okay? And this was your answer. On your bonus, it was a calculator problem, so a lot of you guys put it in a calculator. On the AP test in 2016, it was a non-calculator question, okay? So you had to be comfortable with doing fractions and foiling, okay? So let's look at this problem. I'm going to do it without a calculator, okay? And I want you to follow with me and make sure that you guys are comfortable without a calculator too. If I had to do this without a calculator, I would take out the 1 over 400 because it's a scalar. I would take that out. And then I would say, okay, I would FOIL this inside. What's 3 plus h quantity squared? Oh, is it 3 plus h squared? Oh, thank you. So this is actually h squared and then squared. Thank you. Okay, so then what is 3 plus h squared quantity squared? Is it 9 plus h fourth? Is it 9 plus h to the fourth? What's wrong with that?
We forgot the middle child.
We forgot the middle child. How many of you guys are middle children? Okay, we need to support him, guys. He's the only one here. We need to support him, okay? So, guys, what I forgot here is 9 plus 6h squared plus h to the fourth, dh, all right? And on the outside, I still have this pi over 400, and this right here goes from 0 to 10. Okay? If you had to do this by hand, could you guys integrate these parts by hand? Do you guys see it? It's a buy one, get how many free? What a deal. 2 free, okay? So this would be 9h plus 6 divided by 3, 2h cubed plus h5 over 5 from 0 to 10. And whenever I get this answer, I'm going to multiply it by pi over 400. Okay, you guys with me so far?
Yes.
Okay. First, I'm going to plug in the 10. Charles is with me. Then I'm going to plug in the 0, and when I'm done, I'll multiply by pi over 400. This is a volume, guys. Let me plug in the 10. That's 90 plus, plug in the 10, that's 2,000 plus 10 to the 5th. I guess that's 10,000, 100,000? 100,000 over 5. And then plug in the 0, so you get you see you just get 0 plus 0 plus 0. And then this is the first fundamental theorem of calculus, okay? You take the antiderivative, you plug in the b, you plug in the a, and you slap a minus sign in between, okay? Whenever I get there, are you guys okay if I delete these zeros over zeros? Okay, this is going to be multiplied by pi over 400, all right? And on the AP exam, you can stop right there. Did you guys hear that? On the AP exam, you can stop right there. You will get full credit for the problem, as long as I did it right, okay? As a matter of fact, even to make this simpler, I could have done this. I could have done 9 times 10 plus 2 times 10 to the 3rd plus 10 to the 5th over 5. Make my handwriting clear. And I could have stopped right there. I would have gotten full credit on the AP exam for the free response section. Of course, this wouldn't work on a multiple choice section. And just FYI, it won't work on my test either, okay? But they want you to do this because because some students go from this and the next step is wrong. Does that make sense? And they don't want to count off for those students who go to the next step and accidentally calculate it wrong, okay? But if you do go to the next step and you calculate it wrong, you'll get a point off, okay? This is how the AP test will work, and we'll talk more about the AP test in a second. All right, this question on the 2016 exam also had part A and part B. So this is part A of this question. So let me pull these down. Part A on this question, this was part B, find the volume. Part A was find the average value of the funnel. Can we pull out our pink sheets? Because we're going to need that in a second. Okay. Can you go find an average value equation, that value formula, and tell me what that is on your pink sheet? Average value. What is the average value of F? Do you remember that? What's that on your pink sheet? I think it's on the back of the first page, but I'm not 100% sure. 1 over b minus a times the integral from a to b of f of x dx, okay? And technically, does yours say a to b or does yours say x and 1? X, it says a to b? Okay, well, technically, right, if this is an x, then this would be all x's, if that makes any sense, right? Okay, if this were y, these would be all y's, okay? All right, so we're doing the same thing, but f is not f, f is a radius. Remember what we talked about last year? If they want the average value of your dog, you're going to put your dog here. If they want the average value of f prime, you're going to put f prime here. So if they want the average value of the radius, what are you going to put here? The radius. Does that make sense? Okay, so my new formula is for average value, okay, it's going to be 1 over b minus a from a to b of the radius. Well, the radius is, what is it? Isn't it 1 over 23 plus h squared, right? And then if this is an h, then I'll just say dh here, okay? And if this is a dh, what's my smallest h that I'm looking at? 0. What's my biggest h that I'm looking at? 10. Okay, so if you look at the problem on your bonus, you'll see it said from 0 to 10 on your h, okay? Those are your limits. So guys, what's my b minus a going to be then? 10 minus 0. Does that make sense? Which is just 10. And if I had to do this by hand, which students in 2016 had to do it by hand, I would pull out this scalar, this 1 over 20. I would pull it out, and this would be from 0 to 10 of 3 plus h squared dh. And you can do this by hand. You see the buy one, get one free problem. Yes. Okay, I'll let you do that by hand. All right, and then the third problem on here was a related rates problem. Okay, the third problem is a related rates problem. Okay, and so you can see how how the AP writers are geniuses. They've got one picture, okay, and they're able to test you on 3 concepts in one free response, right? They had a volume question, had an average value question, and here's a related rates question, all right? So you've got your same figure here. It says the funnel contains a liquid that's draining from the bottom. So this thing is full of liquid and it's draining down here. And then it says at the instant. When you guys hear at the instant, what do you think about? Moment in time. Remember, at a moment in time, not all the time, okay? But there was a moment in time, okay? At the instant when the height of the liquid is 3. So at a moment in time, the height is 3. Is the height always 3? No. Only at a moment in time, the height is 3. And if you remember from our related rates days, you can only use the moment in time after you do what? Remember this? After you took the derivative. Okay, that's when the moment in time you're allowed to use it. Okay, so let's look at this problem. At the moment in time when h is equal to 3, the radius of the surface of the liquid is decreasing at a rate of 1/5. When h is equal to 3, something is equal to 1/5. What is equal to 1/5? Think about this in calculus talk. dr dt. So in the moment in time, okay, dr dt is actually equal to, actually not just 1/5, but negative 1/5, right, because it's decreasing, okay? And then the question goes on, it says, at this instant, so at the moment in time, what is the rate of change of the height of the liquid with respect to time? What is this in calculus talk? dh dt. So what you're trying to find is dh dt is equal to what? When h is equal to 3, and at that moment in time, you also know that dr dt is equal to negative 1/5. Everybody get on this problem. Okay, do you remember when we did related rates? We always needed to start with a formula. Okay, so what you do is you look at your picture, okay, and I need a formula that combines this picture with R and with H. You need formula that has this picture with R and with H. Well, it's not a total cone. It's not a total cone. So you can't use like the volume formula because it's not a perfect cone, right? This cone edge is curved in here. Any other formula we have? Let me look at my board. Oh, by golly gee. Look, there's a formula right here. Maybe I could use this formula. Let me write it down. R equals 1/30, 3 plus h squared. Does this formula apply for this picture? Does it have an R in it? Does it have an H in it? Okay. But I don't really want R and H's. I want dh dt and dr dt. How do I move this to dh dt and dr dt? You take the derivative of both sides. With respect to what? Do you remember? Time. And guys, in real life, ddt is way more useful than ddx, you know, in most situations, unless you're doing optimization that's not related to time. But in real life, calculus is used for a lot of time derivatives. Okay, so let's take the derivative of both sides. What's the derivative of r? It's dr dt. I mean, the derivative of r is just 1, right? But since you're doing a dt, you need dr dt. Okay, this 1/30, are you guys okay if I just pull it over as a scalar? Okay, what's the derivative of 3? Derivative of 3, 0. What's the derivative of h squared? 2h. So this is times 2h, but don't forget, guys, dh dt, because I'm taking it with respect to t, and there's an h in the formula. Okay, let's go ahead and figure out what dh dt is, right? Isn't that what I'm trying to find? Well, do I know everything else? I do. Now I can plug in a moment in time because I've already taken the derivative. So what's dr dt? Negative 1/5. Okay. What's what's h? 3. dh dt. And can you guys solve for dh dt? Yes. So dh dt will be, let me multiply, okay, this, did I write this wrong? Sorry. I don't know why I think it's 30. It's 120. Thank you. Okay. So this is really 110, right? So on the right side, I have 3/10. If I multiply both sides by 10/3, I could figure out dh dt. So dh dt is equal to negative 10/15, which isn't simplified. And on the AP test, you don't have to simplify. So if you left it like that, that would be counted right. Okay. But if you simplified, you would get negative 2/3. Okay. If they asked you for units, what would your units be? What's your units for h? Height. What's your unit for height? Inches. What's your unit for time here? Seconds. Is it seconds? How do you know? Very good, seconds. Thank you. Okay, and so there's your answer. Could you have done this on your own? And let's look at the AP test. The way the AP test is going to be, it's divided into two sections. The first section is an hour and 45 minutes. The second section is an hour and 30 minutes. You guys are used to AP tests. I'm assuming this is how most of them are. I don't know. I haven't taken one in like 30 years. I have no idea. Okay, you get a break in between, right? So 10-minute break in between, I think. That's when you can scarf down your food. And the first section is all multiple choice. The second section is all free response. Okay, it's kind of interesting how they do this. The first part is 30 questions with no calculator. Okay, so you'll start out with no calculator. And then I think you seal this up. You seal this part up. You open up another seal. And this part will be 15 questions with a calculator. Okay, so now you can take your calculators out. All right, then when you come back from your break, you'll have your calculators out. Okay, you'll have your calculators out. Okay, and you'll get 2 free response questions that you can use with your calculator because you already have it out. Okay. After those 2 questions are done, you actually won't seal this part. What will happen is that you'll get 4 more questions, and you cannot use a calculator. You'll put your calculator away, but guess what? You can go back to this part without a calculator. Okay, so that's only on the free response, not the multiple choice. But very similar to your test here, right? You can go back to it, you just won't have a calculator to go back to it with. So. And knowing what you know about how they grade the AP test, you could just if you can just get the numbers in, does that make sense? Or even just do the setup, you'll get partial credit. Okay, if you get the numbers in, you'll get the full credit, even if you can't do it without a calculator. Okay? All right, so we'll talk more about the AP test as it gets closer to time, but that's basically what it'll look like. Okay, so what we're gonna talk about is volume. So please pull out your sheet that looks something like this, volume by Shell method. Okay, and what you have here is 2 methods to find this 3D shape, this 3D volume. Okay, and let's start with this first shape, and I want to show you how to set this up. Okay, this was on your test. Okay, that you just took. If I gave you a function, okay, I said this function was y equals f of x. I said revolve this about the y-axis. Okay, what you did was you said, okay, from the axis of rotation through the region to the furthest point on the region, okay, then you would say, is this a dx or dy problem? Dy, right? A thickness of dy. Then you'd say, okay, well, the volume of this, and you can kind of picture what it's looking like. It's like a dome, right? Do you guys see it? There's my 3D. Okay, see, when you put marks like that, it makes it like a volume. Okay, anyway, so this volume is going to be pi r squared, is that right, guys? Pi r squared, okay, dy. And my r here is just it's the length of this line. Everybody good with that? All right. Today I'm going to show you a different method that's going to give you the same answer. Okay. So this is called the disk method. Okay. And I'll put disk here. Today we're going to talk about the cylinder method. Okay. And the cylinder method will give you the same answer. It's just a different way to do the problem. Some problems you have to do the cylinder method. The disk method won't work, okay? And so that's why we teach it to you. The cylinder method says, instead of putting, like, can you guys see that if I take cross sections here, if I took a cross section of this rotated region, if I took out one, do you see it's a disk? Okay? The cylinder method is, instead of taking cross sections this way, take out cylindrical parts of it. Take it out in cylinders, okay? And if you can imagine this piece right here, I mean, just imagine it being rotated, and I take out a cylinder, like a hollow cylinder. You see that? And there's a whole bunch of hollow cylinders. This is a hollow cylinder with the thickness of dx here, but then there's another hollow cylinder that sits next to it I could take out, and then there's another hollow cylinder that sits next to it. You take out a bunch of cylinders and add up all the cylinders, you'll get the volume of this dome. So it's kind of like this. Does that make sense? Instead of cutting it this way, you just take out a cylinder, get the volume of this cylinder, take out another cylinder. And you take out an infinite number of cylinders with the dx width, you add them all together, that's also going to give you your volume. Okay, this is called the Shell method. Does that make sense to you, the cylinder thing? Can you picture it? Okay. And if you want, you can take this home and play with it in the bathtub, and maybe it'll be more clear to you. Okay. But what the formula is, okay, for the cylinder method is, remember the formula up here was if I took out one of these, it was pi r squared times the thickness, right? It was the area times the thickness dy. And that was one of them. And then when I added all of them together, I would get the whole thing, okay? So this is the same thing. I'm going to take the volume of one of these cylinders. Well, it's really hard to take the volume of a cylinder that's hollow, but do you agree that if I cut it open, one of these cylinders and pretend it doesn't have a base, if I cut it open and I open it up, isn't it really just a rectangle with a thickness of dx? Okay, so what is the length of this rectangle going to be? 2 pi r times height, right? So this volume becomes 2 pi r times a height, and then the thickness is a dx. It's just a sliver thickness, okay, dx. So what happens, and you can write this on your notes, is that you get this for a dx cylinder, okay, the length of the solid is 2 pi r, the height is h, the width is dx. So when you multiply them all together, one volume, the volume of one cylinder, one hollow cylinder, they call it a shell, is 2 pi r times h times dx. You just multiply them all together. And if I wanted all of the volumes, okay, the volume is adding all of these cylinders together, then the formula would be, okay, the integral of 2 pi r h dx. You just add them all together. It's the same thing that we did with this, all right? And it turns out this 2 pi is a scalar, so you can move the 2 pi to the outside if you want, okay? Now, r is defined a little bit differently, and our h is actually the same, okay? But now we have two variables in here that we need to put in terms of x. Okay, so let's think about what my r is. My r is going to be the radius of the cylinder, okay? And my h is going to be the height of the cylinder. And that makes a lot of sense, okay? So the radius of the cylinder is going to be from the axis of rotation, so from the axis of rotation to the sliver, I'll say to the sliver, or to the rectangle, or to the dx, whatever you want to call it, to the sliver, okay? And then my height is going to be just the height of the cylinder. So usually it's y minus y or x minus x. The height is a lot easier to figure out. Let's do a problem together, and this will make more sense to you. So flip to the back. Flip to the back of your worksheet, okay? And let's do the problem, the top left together. Okay, on the top left, okay, what they say, you've got this region. One is a parabola, y equals x squared, so go ahead and draw that. X squared plus 1. This is a parabola shifted up by 1. You've got y equals 0, which is this down here. Y equals 0, okay? Then you've got, you're going to rotate this region about the given axis. So this axis is a y-axis. So you're going to rotate this. Let me put the axis here. You're going to rotate this figure about the y-axis between 0 and 2. So I've got 0 here, x equals 0, and x equals 2. X equals 0, x equals 2. Okay, and let me highlight my region. So it's kind of the same as your disk and shell problems in that you have a region and you're going to rotate it. So this is my region. Okay, I'm going to rotate this region. Just in case I need it, I'm going to get this intersection point. If this is 2, what's my y value going to be? I think it's 5. Okay, all right. So what I'm going to do is I'm going to rotate this region around the y-axis. Now, yesterday, if I'd asked you to do this, you would have done, you know, your r value, like capital R would have been here, right? Capital R. And then you would have subtracted your little r right here. Does that make sense? Yesterday, if I'd asked you to do this, you would have done this big old block, and then you would have subtracted this hollowed out block, okay? And you should get the same answer as a cylinder method. Now, the cylinder method is actually a little bit easier on this problem. It won't seem easy at first, but if you are comfortable with it, it'd be easier. Or instead of making a bunch of discs, what we're going to make is a bunch of cylinders. Okay, can you see it? This cylinder is rotating around. Then I'm going to add another cylinder next to it. Then I'm going to add another cylinder next to it. So this formula, it's the same picture, okay, that we're taking the volume of, but this formula is going to be 2 pi RH dx. Now, why is it a dx problem? Had you done the disk method, remember the disk method would have been like this. It would have been a dy problem, right? Okay, with the cylinder method or the shell method, it's just the opposite. The cylinders are parallel to the axis of rotation. And so you can see that this width is a dx width. So this is going to be a dx problem. Okay, now let's think about my radius. My radius, do you agree, of this cylinder would be from the axis of rotation to wherever, whatever cylinder I'm getting the radius of. And the cylinder moves, right? This shell moves. Sometimes the shell is here, sometimes the shell is here. This shell moves. So see if this makes sense to you. We're always going to label this dx as x. Okay, that's the position it's at. It's at the x position. Okay, if we were doing a dy problem, we would label it y. Okay, and so this length. Okay, let me pull it out of the board. This length that I want, because this is my r. Let me label it. This is my r. This length is x minus x. Do you agree? X minus x. So what's this x on this side? This x is just x. But this x is fixed. What's this x on this side? 0. So this r is actually x minus 0. So that's the hardest thing about the shell method, figuring out what r is. And after you do a whole bunch, you're fine with it. Okay, but the first few times it's kind of hard. Okay, so my r is equal to x. And see if that makes sense. Just think about it. What if my cylinder up here? Would that make sense that the radius is x? What if my cylinder a little bit, like it makes sense that your radius is just always x here. Okay, what about my h? So h is a lot easier. H is just the height of this blue region here, the height of this Riemann sum bar, or the height of the sliver. Well, if I pull out h, isn't it just y minus y, right? So this one you're used to. This will be x squared plus 1 minus what? What's the y on the bottom here? 0. So you put this into the equation. Volume equals 2 pi, the integral of x times x squared plus 1 dx. Okay, and this is an x problem. You go to your shaded region. This works just like your disk and washer problems. What's my smallest x on my shaded region? 0. What's my biggest x on my shaded region? 2. Okay, and if you calculate this out, okay, you will get the answer to the volume, which should be the same answer that you got if you did the disk and washer problem. Okay, and online, I will post the answer and show you that it's the same. But right now, famous last words, trust me. Okay, it's going to be the same. So you put this into your calculator, you'll get an answer. Okay, let me set up another one for you just so you can see how these are set up. If you have the same problem, but now you rotate about x equals 1, so go to the right-hand side, guys. Do the same picture, but now we're going to rotate about x equals negative 1. So your axis of rotation here is going to be here. X equals negative 1. Okay, shade the region, same region. Okay, and this point here is going to be 2, 5. And I'm going to go from 0 to 2. And again, I'm going to rotate this about. Now, instead of rotating about the y-axis, though, I'm going to rotate it about this x equals negative 1. So do you see it's a hollowed out thing now? It's kind of like the Roman times, the Colosseum, when they had that big hole in the bottom where they all killed each other. Okay, now we just call it football. Okay, so this thing is hollowed out, and what we're going to do is get the formula for this volume. Okay, so had you done the disk and washer problem, it would have been a dy problem, right? Because you're rotating around a vertical line. The shell method's the opposite. Okay, what you do is you put the Riemann sum bar parallel to your axis. Okay, parallel to your axis of rotation. All right. So as soon as I draw that, I see that it's a dx problem. You guys see that? As soon as you draw, you're like, oh, that's a dx, because it's a width of dx. So let me write my formula for the shell method. It's going to be 2 pi RH dx. Okay. Let me figure out my r now. Okay. Now remember what I said. Your r is, you can see this. Your r is always going to be this. I don't know if I can see it very clearly. I don't know if you can. But it's the r of the cylinder, right? So it's just, whenever you make a cylinder, what's the radius going to be? Anytime you make a cylinder, wouldn't it be from the axis of rotation to your rectangle every time you made a cylinder? Well, what's your r equal to? Well, they call this a small r, so I'll make it a small r, but it doesn't really matter. Okay, this is a small r. So your r is going to be equal to right minus left. Okay, it's always right minus left. On this side, do you remember what I called this? This is always going to be called x. Okay, because it changes, but it's always x. Wherever this cylinder sliver is, it's always going to be a distance x. Okay, this side is -1. So what's the r going to be? X plus 1. Okay, what's your h going to be here? Your h is going to be the height of this thing. Okay, so let me label h here. Okay, pull your h out. What's your h? X squared plus 1 minus 0, right? It's just y minus y, same thing. You've already done that before. So the top y is x squared plus 1. The bottom y is 0. So this formula will be 2 pi times the integral of x plus 1 times x squared plus 1 dx. Okay, this is a dx problem. Again, you look at your region. You say, what's my smallest x? Now, it's got to be the shaded region. Okay, so what's my smallest x? 0. And what's my largest x? 2. And if you integrate that in your calculator, you'll get the answer for this rotation. All right, any questions about cylinder rotation or shell method? I'm not going to do the rest. I'll post it online. And for those of you guys who are curious, okay, this is not on your AP exam, okay? It used to be on the AP exam. They took it out near the bottom. Near the bottom says length of arc or function, okay, S. And so, guys, we call arc length a lot of times S. So you'll see it as S in a lot of books, okay? And what S really is, if this makes sense, it's this. If I wanted, let's say, if I wanted the length of this line right here, let's say this part of the f of x, so call this f of x. If I wanted the length of that from x1 to x2, okay, that would just be some s, some length s, okay? And do you agree that this length s is really just the sum of all these lengths? Because if you think about calculus, what calculus is, it's a bunch of slivers added together all the time. It's differentials, right? It's a whole bunch of delta s's plus another delta s plus another delta s. Well, we know that the deltas get so small that we end up calling them what? Do you remember? ds's. Okay, so all s's is a sum of all my delta s's, which in calculus is really just the integral of all your ds's. I'm going to add all my ds's together, okay? Now, you guys can't see because you're so far away, but I can see that each one of these ds's that I wrote, it's just a line. Like, if you get really close, you can see it's really just a line. It looks like a curve to you guys because you're so far away, but if you wanted to come up here and see, you would see that each one of these ds's is just a line, okay? And the x component of that line is, what do you think? dx, and the y component of that line is dy. So if you go back to the good old days in geometry, ds is actually really just the square root of what? dx squared plus dy squared, okay? And so I'm going to use this to develop your formula that you see on your pink sheet. And what I'm going to do first is going to be a little bit of magic, okay? And that magic looks like this, okay? I'm going to take the same formula that I have, but I'm going to multiply it by dx squared over dx squared. That's allowed, right? Algebraically, did I change the function? I just multiplied by 1. Okay, but what I'd like to do is actually move this bottom dx squared, move it over there. You guys give me that? Am I allowed to do that? Okay. Then what I'm going to do is I'm going to split these into two different square roots. So let me just do it and it'll make sense. I'm going to say this is equal to dx squared times dx squared plus dy squared over dx squared. Am I allowed to do that? If I re-multiplied all this together, would I get that same thing that I had on the top? Okay. I know you guys don't buy it, but too bad, it's true. Okay, so what is the square root of dx squared really, though? Isn't that just dx? Well, there's my dx, and I'm developing my integral, okay? And what is this really? Well, if I do the I heart math and math hearts me, okay, that becomes the square root of 1 plus dy over dx squared dx. And that should be the formula that's on your formula sheet. Oh, it's not? Oh, okay. Well, what do you think I need to do to make it look more like it? Okay, well, is that the same thing? Yeah, it's exactly the same thing. So do you have it on your formula sheet? This is the formula you'll memorize for your test and also for the AP exam. Okay, I need you to know that you can rewrite this. This is very useful when you have f of x equals something, or when you have y equals something, right? Because here you would just take the derivative of y and put it right there, right? And here you would just take the derivative of f, right? The derivative of f and put it right there, okay? But sometimes you're not given things in terms of y. If you're ever given things in terms of x, okay, or if f, you know, if it's f of y, okay, then what you would do is this formula would change to y1 to y2, the square root of 1 plus dx dy squared dy, which is kind of funky. You're like, when would I ever use that? Okay, you would use it if you're given an x equals instead of a y equals. Okay, down here, the equivalent of this would be from y1 to y2 of 1 plus, this would be f prime of y squared dy. I just want to write this, and I'll leave it on the slides to make sure you understand. I know it's not in your pink sheet, but you need to understand that if it were written another way, you could use these formulas, okay, to get the arc length also. The other thing that might help you is another way to write this is just y prime, right? So this is really just y prime squared. Another way to write this is just x prime, okay, x prime squared with respect to y. This would be y prime squared with respect to x, okay? Now, students have trouble memorizing this formula. And it's not because it's very difficult, but there's actually a lot of things going into this formula that you may not realize, okay? There's 4 operations going on here. I don't know if you see it. But if you have antiderivative, you also have a derivative. If you have a square, you also have a square root, okay? So what students do is they'll put the antiderivative, but they won't put the derivative. Or they'll put the square root, but they won't put the square, okay? So do you guys see there are 4 operations in it? Whenever you write the formula, check 4 operations. Make sure you got an antiderivative, a derivative, a square root, okay? And then you'll have arc length. It turns out that arc length, for those of you guys physics enthusiasts, is actually the same thing, exact same thing as distance, okay? And we'll develop the formula for distance from this arc length formula later on, okay? But not now, it's too early. Okay, so what I want to do is do an example problem with you, okay? And I'm going to do one with y equals square root of x, and the other with x equals y squared. And I want to show you you'll get the same answer no matter what, okay? No matter which formula you use, okay? And how to use either one of them. Okay, first I need you guys to just buy in that this f of x here, this picture is y equals square root of x, but it's also x equals y squared for y between 0 and 3. Because remember, x equals y squared picture is this parabola here. And guys, again, I had at least 2 people, if not 3 people, only draw the top part of the parabola on your test, okay? You need to know the horizontal parabola has a top and bottom portion. But there's a limitation here. The boundaries is just this top portion. Y is only positive, okay? So it turns out that these 2 pictures are the same. You agree with that, okay? I'm only going from 0 to 3 on my y limits. So this point here is actually 9, 3. All right, let me get the arc length of this. So what I'm going to do is I'm going to get the arc length of this picture. It's the same picture now, no matter what the formula is. And first, I'm going to do the y equals formula. Okay, so the arc length is equal to the integral of 1 plus, remember, the derivative of y squared dx. Okay, and did I get the formula right? There's an antiderivative, there's a derivative, there's a square root, there's a square. There's 4 operations. I got them all in. Okay, so this is going to be equal to 1 plus, guys, what's the derivative of y? This is really x to the 1/2, right? So what's the derivative of y here? 1/2 x to the negative 1/2. That's equal to 1 over 2 square root of x. But guys, I got to square it. A lot of times students forget to square it. What's the square of 1/2 square root of x? Do you agree it's 1 over 4x? Maybe? Okay. And this is a dx problem. So go look at my curve. What's my smallest x value? 0. What's my largest x value? Or the x value I want to find the length of. 9, okay? So guys, that is going to be the length of this curve, meaning if I put a string on this curve and I took the string off, that's the length of my string, okay? Arc length. All right, this is equal to if I did this formula. So let's do this formula. This formula says, okay, that I take S is equal to the integral of square root of 1 plus x prime squared dy, okay, from y1 to y2. Remember I told you the formulas were the same? Okay, so this S is going to be the integral of 1 plus, what's x prime here? What's the derivative of x here? 2y, right? X prime equals 2y. What's 2y squared? 4y squared, right? dy. What are the limits of my y? For this curve, what's the lowest y value? What's the highest y value? 0 and 3. Okay, guys? If you put this in the calculator and you put this in the calculator, your curve length is going to be exactly the same. Do you believe me? I don't know. Trust me. Okay, so your answer should be 9.747. I don't know if we have time to do it. Yeah, we have time. Let's see if it's true. So go to your calculator. Okay, I'm going to do the left side first. Okay, it's going to be a math 9. Okay, I'll go from 0 to 9. Okay, this will be the square root. So second square root of 1 plus 1 divided by 4x. Oops. Put in parentheses around that just in case I need it. I'm not 100% sure I need it. That'll be an x. Press enter. Oh man, I'm in trouble. Did you guys get it yet? Okay, so 9.747? Yes, okay. Check the other one. So let's go to the right side here. Okay, we're going to do math 9. Okay, from 0 to 3. Okay, in the parentheses, in the integrand, you'll have the square root of 1 plus 4y squared. So I'll just call this an x. My calculator doesn't know the difference. 4x squared. Oops, that wasn't what I wanted. I need that to be a 2. Okay, and this would be an x. Press enter. Do you get the same number? Yes. So do you guys see the x way or the y way? As long as you solve the equation for x and y correctly, and you got the limits correct, okay, then you'll get the same answer. Look at your homework, guys. Your homework is 1 through 6, and also the back side is the pre-cal review. So I expect you to do the pre-cal review. But on the front side, which problem am I going to use for dx, and which problem am I going to use a dy problem for? Remember, the dy's are when you have x equals something. So if you look at your homework, which problem is an x equals something? 6. So number 6, it'll be a dy formula. Does that make sense? On the other ones, because they're all y equals, you'll use the dx formula. Okay, that will be helpful to you. On the back where you have your that unit circle, guys, in calculus we never use degrees, so I don't want to see any degrees on that unit circle. Okay, those diamonds are tangent values, not degree values. Okay, so please put your tangent values in there. I expect you to memorize them, so it's good to go ahead and put them in there and you can see what you have to memorize. Okay, for calculus. You guys feeling good? Yes. Okay, ArcLength is not too hard. Shell method is, but lucky for you, it's not an AP exam.